Hello and welcome to another tech video on this channel. Today in this video, we are going to see how to create a private EKS cluster and access the same via a public facing jump server with an IAM role attached. So without further ado, let's dive into the implementation. So we have already logged into the AWS console. Let's go to VPC, click create VPC, select VPC and more. Under the auto generate, I am writing EKS demo for now. At the end, we will use custom name tags for all the resources. Keeping CIDR, IPv6, tenancy and number of availability zones as default. In production scenario, you may use all three availability zones. I'll have two public subnets reserved for jump server and any internet facing ALBs in the future. Number of private subnets as 4, 2 for app which will have the EKS cluster and the worker nodes, and 2 for databases for future purposes. This will complete our 3-tier network architecture. I'll keep the NAT gateways as in 1AZ. It will be required to download images from ECR. I'm not complicating this implementation by adding VPC endpoints. However, in production scenarios, usually there is no NAT gateway. That time you will have to provision endpoints as well. Once done, I'll uncheck the auto generate checkbox and add name tags as needed. I'm rushing through this part as it's not the most important part of the video. You can pause the video and add tags accordingly. And finally click create VPC. Apart from NAT gateway, all other resources are provisioning quite fast. In the VPC screen, you can see the resource map which helps to visualize the network better. We have completed the basic network infra provisioning required to create a private EKS cluster and its corresponding worker nodes. Now let's move towards the most important part of the tutorial. That is provisioning of the EKS cluster and the node group. On the top, search for EKS. Click add cluster and choose create. In the cluster configuration, give the name as EKS-demo-cluster. Keep the Kubernetes version as 1.25. To pass a cluster service role, you may have to create a new one. For that, go to IAM console. On the left navigation pane, click on roles. Choose create role. Keep AWS service as selected for trusted entity type. Under use case, search for EKS and choose EKS cluster and click next. Here we see Amazon EKS cluster policy is added. Click next. Under the role name, give a name as EKS demo cluster role. Quickly validate everything and click create role. Once the role is created, go back to the EKS screen and click refresh to see the newly created IAM role. Since there is only one cluster role, it got auto-selected. I don't need any secrets encryption for this exercise, but it's ideal for the production scenarios. Adding a name tag as EKS demo cluster. Click next. Choose the VPC which we have provisioned earlier. Remove all subnets and select only app subnets as we want to keep our cluster private. So choosing both EKS demo app private subnets 1A and 1B. I am not creating any additional security groups as EKS will anyways create a security group for the cluster. Choose private as I want the cluster to be private to simulate the production scenario and click next. Since this is a demo, I don't want to enable any kind of logging, but again this is a must for the production setups. kubeproxy, core DNS and VPC CNI add-ons are installed by default. I don't want any guard duty for now and click next. I am not going to touch any add-on settings for this exercise. Click next. Let me quickly verify and review all the cluster parameters and hit create. We can see that the cluster is now in creating state. The cluster creation process will take around 8 to 10 minutes. I will pause the video and come back again once the cluster is provisioned. Here we see that the cluster is now provisioned. Ignore the loading error, it does not concern us for now. Now the next step is to provision compute capacity. For that, go to Compute tab, click Add Node Group. For the name tag, let me add EKS Demo Node Group. Again, we don't have a role created for the node group. Let's quickly create that. Go to IAM console, create role, keep the trusted entities as AWS service, use case as EC2 and click next. In the search box, search for EKS and choose Amazon EKS worker node policy. And another would be required to pull the images from the ECR. For that, search for container and choose Amazon EC2 container registry read only. And click next. Provide the name as EKS demo node group role. Keep all other parameters as is and click create role. Once the role is created, continue with the node group provisioning screen. Once you refresh, the role we just created will be auto-populated if that's the only node group role we have. Keep all other configurations as is and add a name tag, that is EKS demo node group, and click next. Let's keep node group configuration as default, AMI type as Amazon Linux 2, capacity as on demand, instance type as T3 medium, disk size as 20, and keep rest of the configurations as is and click next. Under the networking section, again choose the app private subnets. Configuring remote access to the worker nodes is a personal choice. Some organizations do not allow access to the same. For this exercise, I'll allow access. Go to EC2 console and create a new key pair with the name EKS demo node group key. Keep other things as it is, add a tag and click create key pair. Let's also create a security group. Providing name as EKS demo node group security group. Select EKS demo VPC. For now, I will not add any inbound rules. For this exercise, I won't need any access to the worker nodes, and click create security group. Now let's go back again to the node group creation screen and click refresh button besides the EC2 key pair dropdown and select the EKS demo node group key. Similarly, select the security group as well and click next. Let's quickly verify all the configurations and click create. We see a message stating node group creation is in process. Let's go to the EC2 console to check whether the provisioning has started. I don't see it has started yet. Let's go back to the node group screen and wait for some time. I'll pause the video and come back again once the node group is up. Here we see the node group is active and 2 nodes are registered. Let's check the EC2 console as well. Here we see 2 nodes are provisioned. Now that the provisioning for EKS cluster and the node group is complete, we need to access those cluster and worker nodes. For that, we will require a jump server. We will provision the jump server in the public subnet as we need access to the same from our local machine. For that, let's go to EC2 console, click on launch instances, give the name tag as EKS demo jump server, keep the AMI as Amazon Linux 2023, keep the instance type as is, create a new key pair EKS demo jump server key and hit create key pair. The key pair will be downloaded, which will be later used to access the jump server via SSH. Scroll down to the network settings, click edit, choose the custom VPC we have created earlier, choose any public subnet. This step is important because we will need a public IP for our EC2 instance. So select auto assign public IP as enable, choose create security group, enter a proper group name. I'm keeping the source and port as is since I don't have a static IP. But in production scenarios, it is recommended to restrict access to the jump servers to a single IP so that your entire infrastructure doesn't get exposed. I won't touch rest of the settings and click launch instance. Browse to that instance. It will take some time for that instance to come up. Once it is in the running state, click on the connect button. Go to the SSH client tab. Copy the chmod command. I already have the terminal open. I'll change the directory to downloads. I have the key downloaded earlier in the directory. Paste the chmod command and hit enter. This command will give appropriate permissions on the key so that we can SSH into the jump server. Go back to the AWS console and copy the SSH example string. Paste it in the terminal. Hit enter. Type yes. And now you are able to log into the jump server. From here we can access our EKS cluster and do all the administration required. Now the first step is to install the kubectl tool. Go to your browser and search for install kubectl. Click on the official link from AWS. Scroll down and select the Linux tab. Since we have Amazon Linux 2023, our EKS cluster version is 1.25 and our EC2 instance is AMD 64. Hence we will choose the appropriate link and run it in the terminal. This step is optional. If you want to verify the downloaded binary, I am executing for the sake of it. You can ignore this step if you want. I'll check the checksum as well. It says OK. The OpenSSL command will give a SHA-256 string. You can compare the same with the downloaded one. Again, this is optional. Apply the chmod command to provide execute permissions to kubectl. This command will create a bin directory in the home path. We'll copy the kubectl file in the bin directory and bin directory path will be exported so that we can run kubectl commands from anywhere. Optionally, you can run this command to set the path in your shell initialization file so that kubectl will be accessible whenever you open a new shell session. And finally, run the kubectl command to check the installation. Now, since the EKS cluster was provisioned from an IAM user, we need to configure its credentials in the jump server as the cluster will be accessible only for that particular user. This particular thing is mentioned in the AWS documentation here. This will be done only for the first time. After that, I will demonstrate how to access the cluster via IAM rule. So let's configure the IAM credentials. Execute AWS configure command. Enter the AWS access key, AWS secret key, default region name. For me it is AP South 1 and output format as JSON. If you don't know how to create credentials, I will mention the link in the description. Now our AWS configuration is done. We need to configure access to the EKS cluster from our jump server. For that, let's search for update config kubectl. Open the official documentation link. Copy the update kubeconfig command. Replace the name parameter with our EKS cluster name, which we have mentioned during the provisioning. Replace region code with AP South 1 and execute the command. Here we can see that a new context is added. Now let's validate if it has been added as expected. We can do that using the command kubectl config view. So here we see all the contexts that are configured. As of now, I have only one. If we run the update kubeconfig command for another cluster, it will add another context here. Now let's try to access the cluster using the command kubectl cluster info. Here we see the request is not going through. It's because we have added the context to the jump server, configured the IAM credentials as well, but our EKS cluster has to allow connectivity from the jump server. For that, we will have to open 443 on the EKS cluster security group for jump server security group. For that, let's go to the EKS cluster. Click on the Networking tab. Open the Cluster Security group. Click on the Inbound Rules tab. Edit Inbound Rules. Add a rule in the port range as 443 and in source add the Jump Server Security group. Add appropriate description and click Save Rules. Now head on to the terminal and rerun the cluster info command again. So finally our cluster is accessible from our Jump server. Let's try kubectl get nodes command as well. Here we see the two nodes which were created during the node group creation. We are now able to access the cluster. However, it's not a best practice to access it using IAM credentials. Instead, it should be done via IAM role if we are accessing from an EC2 instance. When you do a configure list, we see list of IAM identities configured in the server. So these are the credentials of my user. And when you do AWS STS get caller identity, it tells you who is running the AWS command. Again, here we see my user is being used. So let's configure our EC2 instance to use a IAM role instead of an IAM user. For that, go to IAM. Go to Roles. Click Create Role. Select AWS Service as Trusted Entity. Keep EC2 selected for Common Use Case. And click Next. Here we are not selecting any policies as we need only Kubernetes access to the EC2 user for now. And for that configuration, no policy is required. In future, if you want to access other services or perform some activities in the EKS cluster, you can provide those permissions. But for accessing the Kubernetes cluster, nothing is required. So ignore the policies and click Next. Under role name, I am giving EKS demo jump server role as the name. Keeping other things as is and click Create Role. Once the role is created, we need to attach the same to the EC2 instance. For that, go to the EC2 instance, choose the jump server, click on the actions, choose security, modify IAM role, choose the IAM role we just created and click update IAM role. Go back to the jump server terminal and check the configure list. We still see the configured user and get caller identity is still showing IAM user as Ajit. But that's okay for now. I'll show how do we clear that in some time. But before that, we have to configure our IAM role in the Kubernetes cluster. Go to the web browser and search for AWS EKS edit config map. Open the link which says enable IAM principal access to your cluster. We have to make changes to AWS auth config map from the kube system namespace. The describe command will give you the details about this particular config map. But before we make any changes, let's take a backup of the config map. You can take the backup using the command kubectl get cm aws-auth-n kube-system and write the output to a file. Validate if the file is created properly. Now execute the command kubectl edit cm aws-auth-kube-system. Here under the map role section, we have to add the newly created jump server role. In the AWS documentation, go to the Edit Config Map Manually tab. We have to add the IAM role information. So let's copy the group section which has some information related to IAM roles. Let's copy this entire group string, paste it in the terminal just below the existing group under map roles. I am giving system master permissions to the IAM role as I want to perform administration from the jump server. Copy the role ARN from the AWS console. I have a typo in the system master. Instead of underscore, it should be a colon. Remove the existing IAM role and paste the jump server role ARN here. Similarly, copy the role name and replace it with the console viewer role. Once done, exit and save. Let's validate whether the config map is updated. So here we see it's been updated with the jump server IAM role. You already know that even with IAM role configured, all the requests to AWS are done via IAM user only. To reset that, let's clear that out by removing the contents of the config and the credentials file. Now rerun the AWS STS get caller identity command. You will notice that it is picking up the IAM role and not the IAM user now. Let's do a kubectl get nodes to check if our cluster is accessible. So this is how you provide access to IAM role on your cluster. When you do an AWS configure list, you will see dynamic credentials generated by the IAM role. Hope this tutorial was helpful to you. If you have any questions or suggestions, please let me know in the comment section. Thanks for watching right till the end. See you in the next video.